The tidal force is a secondary effect of the force of gravity and is responsible for the tides. It arises because the gravitational force exerted by one body on another is not constant across it. The nearest side is attracted more strongly than the farthest side. Thus, the tidal force is differential. Consider the gravitational attraction of the Moon on the oceans nearest to the Moon, the solid Earth, and the oceans farthest from the Moon. There is a mutual attraction between the Moon and the solid Earth which can be considered to act on its center of mass. However, the near oceans are more strongly attracted and, since they are fluid, they approach the Moon slightly, causing a high tide. The far oceans are attracted less. The attraction on the far side oceans could be expected to cause a low tide, but since the solid Earth is attracted more strongly towards the Moon, there is a relative acceleration of those waters in the outwards direction. Viewing the Earth as a whole, we see that all its mass experiences a mutual attraction with that of the Moon, but the near oceans more so than the far oceans, leading to a separation of the two. In a more general usage in celestial mechanics, the expression tidal force can refer to a situation in which a body or material is mainly under the gravitational influence of a second body, but is also perturbed by the gravitational effects of a third body. The perturbing force is sometimes in such cases called the tidal force. It is the difference between the force exerted by the third body on the second and the force exerted by the third body on the first. Explanation: when a body is acted on by the gravity of another body, the field can vary significantly on body 1 between the side of the body facing body 2 and the side facing away from body 2. Figure 2 shows the differential force of gravity on a spherical body exerted by another body. These so-called tidal forces cause strains on both bodies and may distort them or even, in extreme cases, break one or the other apart. The Roche limit is the distance from a planet at which tidal effects would cause an object to disintegrate because the differential force of gravity for the planet overcomes the attraction of the parts of the object for one another. These strains would not occur if the gravitational field were uniform, because a uniform field only causes the entire body to accelerate together in the same direction and at the same rate. Effects of tidal forces. In the case of an infinitesimally small elastic sphere, the effect of a tidal force is to distort the shape of the body without any change in volume. The sphere becomes an ellipsoid with two bulges, pointing towards and away from the other body. Larger objects distort into an ovoid, and are slightly compressed, which is what happens to the Earth's oceans under the action of the Moon. The Earth and Moon rotate about their common center of mass, a barycenter, and the gravitational attraction provides the centripetal force necessary to maintain this motion. To an observer on the Earth, very close to this barycenter, the situation is one of the Earth as body 1 acted upon by the gravity of the Moon as body 2. All parts of the Earth are subject to the Moon's gravitational forces, causing the water in the oceans to redistribute, forming bulges on the sides near the Moon and far from the Moon. When a body rotates while subject to tidal forces, internal friction results in the gradual dissipation of its rotational kinetic energy as heat. If the body is close enough to its primary, this can result in a rotation which is tidally locked to the orbital motion, as in the case of the Earth's Moon. Tidal heating produces dramatic volcanic effects on Jupiter's moon Io. Stresses caused by tidal forces also cause a regular monthly pattern of moonquakes on Earth's moon. Tidal forces contribute to ocean currents which moderate global temperatures by transporting heat energy toward the poles. It has been suggested that in addition to other factors, harmonic beat variations in tidal forcing may contribute to climate changes. However, no strong link has been found to date. Tidal effects become particularly pronounced near small bodies of high mass, such as neutron stars of black holes, where they are responsible for the spaghettification of infalling matter. Tidal forces create the oceanic tide of Earth's oceans, where the attracting bodies of the Moon and, to a lesser extent, the Sun. Tidal forces are also responsible for tidal locking, tidal acceleration, and tidal heating. By generating conducting fluids within the interior of the Earth, tidal forces also affect the Earth's magnetic field.